Hello everyone and welcome to day 7 of Advent of Cyber 2022. Today's room is about CyberChef and it's called Maldocs Roasting on an Open Fire. So let's start out by starting the machine. And so in the previous task, we learned that McSkitty was indeed a victim of a spear phishing campaign that also contained a suspicious looking document. Oh, this is an attack box. All right. Let me go down. Of a spearfishing campaign that also contained a suspicious looking document. Division of Labor Load Share Plan .doc. McSkitty accidentally opened the document, and it's still unknown what this document did in the background. McSkitty has called on the in-house expert forensic McBlue to examine the malicious document and find the domains it redirects to. Malicious documents may contain a suspicious command to get executed when opened and embedded malware as dropped, malware installer component, or may have some C2 domains to connect to. Learning objectives, what is CyberChef, what are the capabilities of CyberChef, how to leverage CyberChef to analyze malicious documents, how to deobfuscate, filter, and pass data. So lab deployment. For today's task, you will need to deploy the machine attached to this task by pressing the green Start Machine button. Located at the top right of the task, we already done that. The machine should launch in split view. If it doesn't, you need to press the button Show Split View. CyberChef overview. CyberChef is a web-based application used to slice, dice, encode, decode, parse, analyze data or files. The CyberChef layout is explained below. An offline version of CyberChef is bookmarked in Firefox on the machine attached on this task. So add the text of file in panel 1. All right. Panel 2 contains various functions. Panel 2 contains various functions, also known as recipes, that we use to encode, decode, parse, search, or filter data. Drag the functions or recipes from panel 2 into panel 3 to create a recipe. The output from the recipes is shown in panel 4. Click on Bake to run the functions added in panel 3 in order. We can select Auto Bake to automatically run the recipes as they are added. Alright, using CyberChef for malware doc analysis. Let's utilize the functions, also known as recipe, from the left panel in CyberChef to analyze the malicious doc. Each step is explained below. So let's follow along and do the exercise along with the room. All right, CyberChef is right here. All right, so here we have CyberChef. So let's add the document. Can I have this in full screen, please? Thank you. And I can exit split view. This is better. Alrighty. And let's add the doc to the input. All right, here we have it. Just some nonsense, some encoded nonsense. So it is not very readable. Name of the file, size, application, and it has been loaded 100%. So very good. Let's go back to the section. Add the file to CyberChef. All right. Extract strings. So strings are ASCII and Unicode printable sequences of characters within a file. We are interested in the strings embedded in the file that could lead us to suspicious domains. Use the strings function from the left panel to extract the strings by dragging it to panel 3 and selecting all printable characters as shown below. All right. So let's try it out from the left. Let's search for the strings recipe. All right. Nice. So a lot of strings on this one. Let's check if we have some URL on it. Actually, let's not go into it by ourselves. Let's follow the exercise. So all printable characters are shown below. Yes. If we examine the result, we can see some random strings of different lengths and some obfuscated strings. Narrow down the search to show the strings with a larger length. Keep increasing the number of length until you remove all the noise and are only left with the meaningful strings as shown below. All right, so minimal 258 to start. All right, remove pattern. Attackers often add random characters to obfuscate the actual value. If we examine, we can find some repeated characters. Yes, as these characters are common in different places, we use rejects regular expressions within the find/replace function to find and remove these repeated characters. To use rejects, we will put characters within the square brackets and use backslash to escape characters. In this case, the final rejects will be all right, where /n represents the line feed as shown below. So let's add the find and replace. So find and replace operation. Let us find this one right here. Let's use the clipboard. All right. There we go. We have found a command. So cmd/message username would x. Experience an error trying to open the file. PowerShell hidden encoded. So something is it's starting to be more readable. It's evident from the result that we are dealing with a PowerShell script, and it is using base64 encoded string to hide the actual code. Yes. So drop bytes. To get access to the base64 string, we need to remove the extra bytes from the top. Let's use the drop bytes function and keep increasing the number until the top bytes are removed. All right, so 124 is the number that they give us. So let's use the drop. Let's use the drop bytes function. 124, which is the length of that first line of bytes, and we now have the byte 64 encoded encoded text. As we can see right here, the double equal show us that we are indeed dealing with byte 64. Decode base 64. Now we are only left with the base 64 text. We will use from base 64 function to decode this string as shown below. So let's do it. Let's use base from base 62. No, from base 64. Here it is. All right, there we go. Set variable, etc., etc. It's a bit hard to read as well because we can see that these two characters, the dot and the parentheses, they are repeated a lot. So it's probably another find and replace function to remove this. Decode UTF-16. The base 64 decoded result clearly indicates a PowerShell script which seems like an interesting finding. In general, the PowerShell scripts use the Unicode UTF-16LE encoding by default. We will be using the decode text function to decode the result into UTF-16E as shown below. Okay, so this is actually another encode on the function. So let's use decode text and select UTF-16/LE. So decode text. All right, decode text. UTF-8, no, UTF-16/LE. There we go. Much better. So it is getting more readable. So we can see that it still has some dashes where it shouldn't. For example, on the replace, some strange capital letters. Find and remove common patterns. So this is what I was talking about. Forensic McBlue observes various repeat characters, such as this dash, parenthesis, plus, within the output, which makes the result a bit messy. Let's use regex in the find/replace function again to remove these characters as shown below. So yes. So this was very obvious from the last step. So let's add one more function, again the find/replace, and let me again use the clipboard. Okay, let me all right, there we go, getting much smaller, much readable. It still has some, well, we can see a URL, or not a URL, but this is a path to a mystery gif.exe, and all right, and maybe a URL right here. Yes, definitely a URL. So I would say maybe another encode, because we still have some strange characters in here. So oh no, another find and replace. If we examine the output, we will find various domains and some weird letters before each domain reference. A replace function is also found below. That seems to replace this with this. Replace, yes. So let's use the find and replace again to replace the HTTP, to replace these characters from the with the HTTP. So another find and replace. Yes, I need to use this again, the clipboard. Here's so find this and replace it with HTTP. There we go. So we should probably be able to see this. Yes, so it's much readable right now. So HTTPS www.secretsanta.dhm golden ticket, and we have a flag right here. Extract URLs. The result clearly shows some domains, which is what we expect to find. We will use the extract URL functions to extract the URLs from the result as shown below. So let's use another function called extract URL. Extract URLs. Did it work? No. There we go. And we have now 2 complete URLs. 3 complete URLs. Yes, so this is probably several paths. But yeah, we did it. So split URLs with add. The results show each domain is followed by the add character, which can be removed using the split function as shown below. So let's split it with All right, a paragraph and an add. So let's use the split function. Split. So split with add. There we go. Yes, so much readable. So it's getting much better. So we actually have 4 URLs. One of them is Google, but we actually have 4. So defang URL. Great. We have finally extracted the URLs from the malicious document. It looks like the document was indeed malicious and was downloading a malicious program from a suspicious domain. Before passing these documents to the SOC team for deep malware analysis, it is recommended to defang them to avoid accidental clicks. Defanging URLs makes them unclickable. We will use defang URL to do the task as shown below. So this is very, very, very cool tool. So defang URL. So defang URL. It should be automatic, right? Yes. So there we go. It changes some of the characters and it adds some parentheses so we don't automatically click these URLs when we pass it, for example, through email or another document. So what we really had on this room is an explanation on how to use a tool to first start malware analysis. So almost every type of malware is obfuscated, encoded, and with random and useless characters on it. So defenders can't really make any reason of what's happening on the code, and using tools like this one, and even hard coding some rejects on, for example, a Python language or another automated tool is the place to start when you are first analyzing a malware file. So CyberChef is very, very cool in this automated process. So let's now go into the flags of this exercise. It should be straightforward since we followed the exercise. What is the version of CyberChef found in the attached VM? So version 9.49.0. So 9.49.0. How many recipes were used to extract URLs from the malicious doc? How many? Let's count them out. So 1 strings, where we first replaced these random characters that were used to trick us and to obfuscate some code. So 1 strings, 2 drop bytes, what else is this? From base 64, 3 in decode text, 4 find and replace, 5 find and replace again, 6 extract URLs, 7 and defang 8. Oh, it has 2 characters, really? Did I forget some of it? Probably. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, and split 10. All right. So 10 functions. We found a URL that was downloading a suspicious file. What is the name of that malware? So it is mysterious gift .exe. Mystery gift .exe. All right. What is the last defanged URL of the Bandit Yeti domain found in the last tab? The last defanged URL is this one. So in the last step, it should be, yes, with the defanged function on it. So great. Here we go. Yes, nice. What is a ticket found in one of the domains? Format domain and then the golden flag. So it is the golden the golden ticket. There we go. So it should be like this. No. Have another. No. Format domain slash golden flag. Do you want just a flag? Yes. All right. If you need, if you like the investigation today, you might also enjoy the security information and event management module. So a very cool, very interactive room with the introductions on obfuscated malware and the first hands-on on malware analysis. So we had some show of some very important functions, decoding functions, some regex functions, and of course the replace and split, so this code can get more readable. Even in the end, we had some the important care of defanging the URLs. So when we pass it to the next person to analyze, we are already protecting them. So guys, I hope you have enjoyed. I hope you have learned something new with this room. And thank you very much for watching, and Merry Christmas, guys.